All right, so here we want to find all roots of this third degree polynomial. F of x equals x cubed plus 2x squared minus 5x minus 6. Okay. So first things first, we know that there's going to be three roots, right, or three solutions because of the leading power here is x cubed, right? So we need a starting point, and that's where we're going to use the rational zeros theorem, right? So we're going to get our p's and q's here, right? So p is going to be all factors of the last number, which is 1, 2, 3, and 6, right? All of these numbers, if you multiply them, they go into 6 evenly, right? Q is going to be all the factors of the leading term, right? The leading term here is just 1. So then what does that mean? It means that all possible combinations of plus or minus P over Q are the possible rational roots, right? So in this case, we're going to get 1, 2, 3, and 6, including the negatives. That means there are 8 possible rational roots, okay? So we know that one of them should work, right? So how do we know? What do we know? Okay, if we plug it into the polynomial, okay, we should get 0, right? Then that means that it's a factor, and we found one of the solutions. Okay, so let's just start out with 1, right? We'll plug in f of 1, and hopefully we get 0 here, right? So we get 1 cubed plus 2 times 1 squared minus 5 times 1 minus 6. Okay? So we get 1 plus 2 minus 5 minus 6. Okay, this is 3 minus 5, negative 2, we get negative 8. Okay. So f of 1 equals negative 8, which means that 1 is not going to be a solution, right? So let's just try negative 1. Right, so we'll plug in the negative 1 cubed plus 2 times negative 1 squared minus 5 times negative 1 minus 6, right? Here we get negative 1 cubed, we get negative 1 plus 2 plus 5 minus 6. Okay, and this one, we actually do get 0 as the answer, right? So what does that mean? It means that negative 1 is one of the 3 solutions, right? So what do we do next? Now that we found a solution, what do we do, right? Then we go straight into synthetic division, right? We want to break down this polynomial. So let's break down this polynomial. We'll divide by negative 1. So we get 1, 2, negative 5, negative 6. Okay, so we'll bring down to 1. We get negative 1 here. Add these together. Negative 1 times 1 is negative 1. We'll add these to get negative 6. Negative 6 times negative 1 is positive 6. And look what happens, right? We get a 0 as the remainder, which we expected to. Okay? But what was the whole point of dividing, right? The whole point is to get these 3 numbers. These 3 numbers represent, okay? So actually, if we get this third degree polynomial, it should equal x plus 1 times whatever these 3 numbers are, right? X squared plus x minus 6, right? If we multiplied these 2 polynomials together, we would get this guy right here, right? So we're sort of just breaking them down. Okay? Remember, we knew that because we figured out that negative 1 was a root. Okay? So now, what are we left with? We are left with finding the solutions of this quadratic equation. And actually, in this case, this one is factorable. So we should be able to find the solutions pretty straightforward here, right? So we'll factor this. And of course, we still have that x plus 1 factor, okay? So what can we conclude? That this original polynomial can be factored pretty evenly or pretty nicely into this guy right here. Which means that what are our 3 solutions? Our 3 solutions are negative 1, negative 3, and positive 2.